Hello, everybody. My name is Jay Anda, and I'll be moderating our session today. So we've had some great conversations today or over the last 2 days, and insights throughout the summit. And in this session, we'll be talking about Carbontech. So carbon emission remain the single largest contributor to greenhouse gases, and its mitigation is central to the fight against climate change. Earlier this month, we saw the world's largest direct-to-air capture plant, the Orga plant, come online in Iceland. And it'll be responsible for removing 4,000 metric tons of carbon dioxide from the air per year. Amongst many other initiatives, we're seeing how Carbontech will be a catalyst for mitigating climate change. So today, it gives me great pleasure to be able to host 4 amazing speakers. So just as a quick background, Frederick Clare, Director of the Carbon to Value Initiative at Urban Future Lab. Carbon to Value is a new multi-year initiative to accelerate Carbontech as the next major frontier in climate change solutions. This effort is in partnership with Greentown Labs, Fraunhofer, and supported by NYSERDA. Aaron Fitzgerald, CEO and co-founder of Mars Materials. Mars aims to sequester captured CO2 back into the supply chain for use in everyday products such as durable plastics, rubbers, and carbon fibers. As a public benefit corporation, their mission is to use market-driven approaches to commercialize technologies capable of removing and sequestering greenhouse gases. Clea Kolster, Director of Science at Lower Carbon Capital. Lower Carbon Capital invests in solutions that reduce or remove the amount of carbon in the atmosphere and buy more time for those on the front line of climate change impacts. Clea has focused her career on decarbonization technologies from her PhD in chemical engineering, focused on large-scale carbon capture and storage, to her work with state agencies, asset owners, and utilities on their decarbonization plans. And today, helps identify and builds companies that have the potential to un-F the planet and make lots of money at the same time. And lastly, Philip Pienkos, founder and CEO at Polaris Renewables and emeritus scientist at the National Renewable Energy Laboratory, and grandpa. Polaris Renewables is developing proprietary technology for the production of fully renewable non-isocyanate polyurethanes for use in foams, coatings, and adhesives with footwear, fabrics, and outdoor gear. So welcome, everybody. And as a way of introduction, I'd like to start off by asking each one of our panelists for a quick hello and to ask what makes you passionate about Carbontech. And let me start with you, Frederick.
Great. Yeah. Thanks so much for having me. It's a pleasure to be with you. You introduced the Carbon to Value initiative, and it's also in partnership with the Urban Future Lab, which I am affiliated to, which is a New York City climate tech incubator. I would say, my passion for Carbontech is really around the intersection of decarbonization and circular economy. So I think you can definitely decarbonize the economy but keep something very linear. So going from raw material to extraction. And I think we need both, like building circular value chains and decarbonize at the same time. And I think we'll talk more about it today, but I think Carbontech is a great solution to achieve both at the same time.
Thank you. Aaron?
Yeah, so for my passion, and thank you for moderating this panel, Jay, it really, for me, starts with Hurricane Katrina, where I started to take small personal steps to be a better steward towards the environment. Over that time, I became really diligent on tracking my carbon footprint every year and choosing what not to drive and where not to live based off of environmental factors. But it wasn't until a few years ago when I started to work directly in climate, I joined a company called Kairos Aerospace, where the founders invented a remote sensing instrument that could detect super emitting methane leaks. And during my time there, we surveyed oil and gas operators and landfills, and we saw how leaky these facilities were. And I really wanted to do something about it. So I set out to learn why nothing was being done, what could be done, and ultimately I decided to be the change that I think we needed. So I'm here today and really excited to be on this panel.
Fantastic. Thank you. Clea?
Yeah, thanks, Jay. Very excited to be here and to see how many people are working on this today and interested in getting into this. I think not long ago, this used to be a very small group and needs to be a much larger one. I'm probably going to repeat this a few times during this session, but just as a reminder, everything that we use, eat, walk on, move with is in some way, shape, or form made or fueled by carbon. So today I'm excited about the fact that so much incredible science and technology has been developed that's actually starting to make it possible to convert carbon into all the things that we need today, and convert removed CO2 into that. So that's what I work on every day, and that's what I'm excited to talk about today.
Thank you. And Philip, please.
So I worked in startups for about 20 years before I moved to the National Renewable Energy Lab. And when I got there, I was just blown away by the shared mission and the sense that the work going on there could really make a difference in the world. That became very, very important to me. But at the same time, I was working in biofuel area, and I saw the failure of cellulosic biofuel to get commercial. And I realized that some of the mistakes made were the failure to really nail down the supply chain and the need to compete on cost. And so it really sort of brought in the experience that I had in startups, where you've got to nail those things down before you go commercial. These were very expensive failures, and they were very disappointing to everybody, not just, of course, the folks directly involved, but to us in the trenches at NREL working on these technologies. So I came to realize that you need to bring the sorts of skills that startups have. You need to know that you've got a saleable product. You need to know that you can bring that product in at the quality needed, and you can bring it in at a price necessary for the consumers to buy it. And so when one of the things I worked on was to try and drive the price down for biofuel production, and that was renewable polymers. And I really got so excited about the renewable polymers, the non-isocyanate polyurethanes that you mentioned, that I realized that this was something that could really take the lessons of my early days in startup and the lessons I learned at NREL and actually make a difference. And so as a grandpa, I'm aware of the fact that I spent a lot of my life polluting the earth, and that I'm trying not to leave such a bad place to my granddaughter.
Love it. That's so lovely. We have a pretty mixed and broad audience today. So just like to start off by taking a quick step back. And Philip, if you don't mind starting it off, can you help us define what Carbontech is, and what's changed technologically that enables carbon to become a valuable input rather than negative output?
Yeah, thank you. That's a good question. So I define Carbontech as the ability to place CO2 into a saleable product, right? And this typically involves some form of organic chemistry to turn CO2 into a fuel or a chemical or a product of some sort that actually has the potential to be sold on the marketplace. And so this is something that we've looked at in a lot of different areas. And one of my biofuel background was working with algae, which use photosynthesis to do Carbontech. They take the solar energy and use that in order to take carbon dioxide, turn it into sugars, and then turn it eventually into the rest of the algal cell. So people are getting very clever about using chemistry and using biology in order to capture CO2 and place it into products that they can bring to market. In terms of the changes that are necessary, it's not just technological advances, but it's really perceptual advances as well. Because once it became clear that of the problem of climate change, and if it's not clear today, it's never going to get clear. People that were very creative began to realize we can reduce the amount of carbon, reduce the amount of petroleum that we're burning, but we can also capture that CO2 and do something with it besides trying to pump it underground in order to bring up more petroleum and increase the problem. So with this perceptual change, then came, I think, a huge change in creativity in the technical areas in order to develop new ideas, new technologies in order to enable Carbontech. In terms of a technological advance, I think the biggest one is one that we've seen there's a panel going on right now and a panel that was on earlier today about the ability to generate cheap electricity, right? Cheap power, cheap renewable power, and the fact that the electric grids, power grids, aren't able to take all of that material. And so a lot of this power, a lot of these electrons can go to waste. They're either going to be free or, well, cheap or free. And so with the advance of this renewable electricity, and free electricity, we now have the capability of driving a lot of the concepts in Carbontech. And one example I'll use, it's a biological one. I'm a biologist. It's a biological example. It was a reaction that I thought was absolutely crazy. There's a microorganism that can take hydrogen and CO2 and use it to make methane. And I thought, my God, don't we have enough methane, right? Don't we have biogas? Do we really need this? But as I looked into it and realized you need hydrogen in order to do this. And if you've got hydrogen that's free or almost free from electrolysis, then this reaction starts to make sense. So with the advance of the perceptual change and the advance of the technology, things that were would have sounded ridiculous 20 years ago now make a lot of sense.
Thank you. And so it sounds like there's a lot of moving parts to enable Carbontech. And Clea, maybe if we could just kind of have a broad scope of what that value chain looks like.
Yeah, sure. So, I mean, to start off with, CO2 has a value today, right? We use about 250 million tons of it on an annual basis. It's an industry about $5 billion in size. That CO2 mainly comes from fossil fuels today, and about half of that is used in fertilizer production. About a third of that is used for, I think, what Philip was referring to as CO2 for enhanced oil recovery, and then smaller uses in food and beverage, stimulating plant growth, and things like metal fabrication. And depending on its end use, people will pay anywhere between $300 per ton of CO2 up to several $100s per ton of CO2. Now, obviously, there's something wrong with that because we have a lot of CO2 that we are emitting into the atmosphere that already is sitting in the atmosphere that we could be using instead. And to some of Philip's points around, there has been perhaps a perception change, but I do really think that most of the change that we will see is in this space is driven by the fact that technology has materially shifted. We are able to have cheap, clean electricity to drive advances in electrochemistry that are actually able to convert CO2 into fuels and valuable chemicals. Synthetic biology has become a huge lever in the ability to sequence DNA very cheaply and better understand both cell-free and cell-based systems in their conversion of CO2 into chemicals. All of those things are driving the fact that we can actually make things today through upcycled CO2 at a cost competitive point. And that's what makes me very excited about it. The Carbontech value chain exists and it's going to be expanded to integrate CO2 into more and more products.
Thank you. Frederick, you want to chime in from your perspective as well?
Yeah, and maybe just to add on that I think it's useful for the audience to differentiate where the CO2 is coming from. So whether it's like from an existing fossil fuel source or hard to abate sector like fertilizer production or steel making or concrete making. I think Carbontech could be a really good solution for anything that we cannot electrify easily. So power will get electrified pretty fast, EVs. But for long-haul trucking, for aviation, even for maritime fuels, fuels produced through Carbontech could be really, really interesting. And then you can capture CO2 from the atmosphere, whether it's through technological means like direct air capture, like you mentioned, Jay, with the Orca plant in Iceland, or through photosynthesis. I think Philip mentioned it too, using plant biomass, basically using photosynthesis as a natural mean to capture carbon, and then you use the biomass you convert it into a product. And so it's actually a really complicated space because you have feedstock options, many different feedstock options, where the CO2 is coming from, many different pathway, electrochemical, biological, photocatalystical, thermochemical, and then you have a lot of different product options. And I think one of the barriers that we see when you start a company in Carbontech is really like, oh my God, like what is the right combination that will work in phase 1, like 0 to 5 years, in phase 2, to 5 to 10, and then in phase 3, over 10 years, and what are the risks, each time associated with each of these phases. And so, yeah, it's a kind of an exciting space, but it's also very kind of complex combination from a combination perspective. Space, and maybe I'm sure we'll talk more about the products later too.
Cool, thank you. And so, Aaron, you're going all in as a startup founder. What role does Carbontech play in the broader climate mitigation strategies? How do you see the world from your lens?
Yeah. So the way I see it right now, we don't have effective mechanisms to remove carbon from the air, or at least cost-effective mechanisms to do so. We also don't have the tools to decarbonize industry at the scale that we need. So for my first point, we have companies like Microsoft, Stripe, Spotify, who are footing the bill today to remove carbon from the air. And I see Carbontech as another player to help subsidize the true cost of carbon removal. And then secondly, I also see Carbontech as being a critical tool for decarbonizing industry more broadly. And we are extremely behind on this, I think, as we all just mentioned. And all the models say that we need heavy decarbonization in addition to carbon removal. So carbon removal, I think, Carbontech sits at this unique nexus to achieve both these goals. And I think that's pretty promising. And that's really what we're trying to work on at Mars.
Great. Yeah, there's a lot of research being done. Oh, sorry, go ahead.
Oh, no, go.
Okay. Yeah, it's really interesting you said that, there's a lot of research being done with the Circular Carbon Network that mentioned that over the last decade, over 330 innovators are working on carbon removal, turning carbon into value, of which there's been about $2.2 billion of funding. And then a group called Carbon 180 has estimated that the TAM for carbon to value market is projected to be over $6 trillion. And so I think there's lots of different ways to actually do this. And we're kind of at the early stages of making this happen. Frederick or Clea, can you illustrate how carbon actually turns into value? Like, how do we sell this?
Sure. I can just start by just to add on to Aaron's previous point. We need gigatons of CO2 to be removed from the atmosphere, and that's separate from the fact that there are several industries right now that we don't know how to decarbonize, and their principal solution is point source capture. To Frederick's point, but ultimately, in addition to that, we already have too much CO2 in the atmosphere. So, and we need to remove gigatons of it. And while hopefully corporations are going to get their act together and start being accountable for the CO2 that they've put into the atmosphere, realistically, we only really get to that $1 trillion level of CO2 removal if there's some productive use for it. And so, I'm excited about talking about some of the different values that CO2 can have. But why not displace a lot of the fossil fuel-based processes with removed or captured CO2 as an input instead? One example that has kind of come up in the news quite a bit lately is around shipping fuels. 3% of all emissions come from shipping, and right now they use a very dirty fuel called bunker fuel, and one of the largest shipping companies in the world, Maersk, has made some recent announcements, while small in the grand scheme of things, but in switching their fuels to green methanol. And what green methanol means is combining clean or removed CO2 and green hydrogen into producing carbon neutral methanol, which has huge implications both in the burning of the fuel and continuing to create that value for more removed CO2.
Can I just play off of that and just dive a little bit deeper? Is that like a one-click switch over between the different types of fuel types? Like what's involved to actually create, that to create change?
Yeah. It's not a one-click switch over. They've invested significant sums of money to switch over their engines to methanol-based engines, but the whole shipping industry is starting to get pushed on this, because not only do they emit CO2, but they emit lots of other pollutants that they're starting to actually get reprimanded for, like NOx and SOx and particulate matter. So there is both the regulatory play here, but also the fact that with a methanol-based engine, they can use a much cleaner fuel.
Great. And Frederick, go ahead, please.
Can I jump in, Jay?
Absolutely, please do.
So Polaris is developing technology for renewable polymers, and the reason we're in Carbontech is because our polymerization chemistry actually captures CO2 and places CO2 directly in the polymer chain, which is great, right? And we've recently learned that our polymers are biodegradable, also great. But we realize that with a biodegradable polymer, all we're doing in Carbontech is borrowing the CO2 for a while, and we're putting it back into the atmosphere, right? And so it can't be just about Carbontech. It has to be about taking the carbon out and leaving it out. Well, okay, plastics do that, right? Then they end up in the ocean, they never go away. That's not the solution either. And so everything that's also going into the circular economy, to reusing that carbon over and over again, keeping it out of the water, out of the landfill, and out of the atmosphere. That's a critical element to this.
Yeah, absolutely.
100%.
Absolutely. Since we're talking about all the impact that you're doing, we'll bring it over to Aaron, and maybe you could share a little bit more about your contributions on how you're turning carbon into value.
Sure. So at Mars, we are partnering with NREL, which is the National Renewable Energy Laboratory, to commercialize nitrylation, which is a novel method to produce low-cost, low-carbon acrylonitrile. Acrylonitrile is a nearly $12 billion commodity monomer market, and it has many downstream uses. And really most exciting to us is in its polymerized form, it becomes PAN, which is polyacrylonitrile, and that's the main raw material for carbon fiber. Carbon fiber itself has a lot of downstream decarbonization potential, in addition to being able to be used as a direct replacement for hard to decarbonize materials like steel and aluminum. So we see a lot of promise in our technology, even at our small scale today, where it can achieve cost parity. And then in the long term, where we're able to reach our commercial scale, where we're able to reduce costs significantly. And in that case, I think what's working for us as we are trying to achieve our big goals of gigaton scale carbon sequestration into a product are kind of three areas where we see really good market pull. We see a lot of people and talent coming into the space, and we see an ecosystem being developed underneath our feet. And just starting with the first one, we are now starting to see a lot of corporate consensus around climate action. And this is really inspiring for us, because finding interested partners in corporations, I don't think has ever been easier. There hasn't been a better time to jump into the Carbontech space. We've been in talks with manufacturers who are traditionally known to be very secretive and quite slow to adopt new technologies, but they're all looking for ways to decarbonize. And they're looking for startups like us to help them solve their, to help them with their plans. And then further, and I think as it relates to Fred's initiative at Carbon to Value, there's a lot of attention and dollars going into the carbon to value space particularly. When it comes to talent, I really don't think there's a better time to recruit than now. There are so many talented and passionate people around the world who are extremely interested in solving this problem. And what I will say to the audience here today is that, if you're on the sidelines and you want to get involved in climate or Carbontech, you don't know where you fit in, reach out to us. We might not have the funds to hire you today, but it could happen in 3 months, 6 months, because we need you. We need this. We need as many bodies as we can on deck helping to solve this problem. And then lastly is that ecosystem. When I set out a couple years ago to investigate why decarbonization was really slow and how we could reverse greenhouse gas emissions, there was not a clear path for a non-technical founder like myself to have the impact and to have impact in the way that I know that I can. And in just 2 short years, we have programs like Venture for Climate Tech, Carbon and Value popping up and really providing that support for entrepreneurs to not just have the runway to kind of cross the valley of death, but also to connect with the stakeholders that are necessary to bring these businesses online.
Great. And Frederick, from your perspective, you're kind of in the center of that ecosystem as well. What other trends do you see? What are you seeing, and things that the audience should be aware of as we're gaining momentum?
Yeah, I think for the audience, it's useful to get a couple of examples of how to turn carbon into value. We talk about fuel, chemicals, materials, but what are these? Just to give you some example from what we see at CDOE, we received 130 applications, and we ended up selecting 10 companies, of which Maersk material is one, making carbon fiber, very high added value material, very interesting. There's a company making methanol and ethanol. It's called Airco. And the first beachhead that they found is selling ethanol as a vodka. And that's going to sell, 10 times, up to 100 times the value of ethanol as a fuel. So very high added value there. And that's, I think, an interesting trend that we see in the sector is playing with the consumer brand or building your own consumer brand so that you can capture a lot of value that's at the end of the value chain. Because if you're trying to sell an intermediate and sell, as a supplier to big chemicals company, you're going to really get crushed on the margins. Other examples include production of ethylene, which is a nice precursor to polyethylene and polyethylene terephthalate, which is the bottle material that's, Coke and the likes are desperate to find alternatives. They have over almost the last decade launched several challenges to find alternatives to PET, and that's going to sell between $1,000 and $2,000 per ton. Then we have a company like Carbon Free who's mineralizing CO2 into carbonates, and that's interesting because it's actually sequestering the CO2 into materials you can use in construction or as a chemical for household products or agriculture. There is another company using biochar, so biomass pulverized, kind of concentrated into only carbon matter, and then this char can historically be used in agriculture, but they found a new applications in building materials to blend it with plastics, and they can blend up to 70%, which is a very high ratio. Historically, you could blend, and probably Philip, you know that better than I do. Usually in biopolymers, you can blend 30%. You're quite happy. You can blend 30% of bio with a fossil-based. We just have a lot of different exciting companies. And I think one product we haven't talked about is carbon removal as a service. I mean, it's not a product that you can use every day, but I think it's increasingly becoming a potential product. And we're seeing companies like Microsoft, Shopify, and Stripe being very early adopter of this kind of product. And it will be very interesting to see, if government going to jump into buying this kind of products, and if these early adopters will be able to kind of attract more corporates and more buyers to this space. Because at the end of the day, I think Claire mentioned it, we need to remove carbon out of the atmosphere. And it's not a tangible product that can be useful today, but it's definitely something that we will benefit from 10, 20, 100 years from now.
Thank you. And so, it's great to hear that there's so much energy and support on the ecosystem. The entrepreneurs have it the hardest, right? They're trying to do something that's breakthrough and go through these challenges. So for Aaron and Philip, what are some of the immediate challenges that you and perhaps other entrepreneurs in the audience are facing?
Sure, I'll go first. I think I mentioned earlier, the valley of death is real. As an entrepreneur, I feel it. And I think if we're all as committed to throwing as many climate shots on goal as we need, I think we need better mechanisms to help startups cross this valley of death. And I have a couple ideas, and I'm sure folks will probably disagree, but I think one big change we need to see are a change in the the fundraising cycles for like DOE, SBIR, and STTR. Those programs should be available on a rolling basis. Other things I think we need to see are more programs like Venture for Climate Tech and Carbon of Value to help bridge those gaps between idea to investment. And then finally, I would say I'm seeing a trend for fellowships. I was a Carbon 180 entrepreneur in residence for a year. That gave me the runway to do a technology discovery search that allowed us to down select nitrylation. We need more of those programs to support underrepresented founders like myself as a queer Black man. Folks aren't necessarily throwing dollars at me all the time. So I think if we're able to kind of solve those kind of three buckets, we'll start seeing a lot more innovation happening in the space and more companies popping up.
Thank you. Philip?
Yeah, for me, things just are moving too slow. I mean, despite all of the advances, bringing products to market on the scale necessary in order to do something about our climate crisis, it's just not happening fast enough. And I look at my own, I think Polaris is making great strides. We've been making great strides as a company. Right now, we're chasing down a lot of grant funding. Well, if we get the grant funding, that'll start flowing next year. Projects start maybe by 2023. We will have our minimum viable prototype. Another year or so to get that into pilot and then onto the market. This is just not fast enough. And, I'm at an age where the days go slow and the years go fast. I got a late start founding Polaris, and I'm trying to make up for lost time, but it's maddening to see how slow things go.
Yeah, understood. Hopefully the funding cycle will shorten and more investors like Lower Carbon will pop up and do amazing things. I think even throughout this conversation, we talked about cost and the sophisticated supply chain of the materials industry, right? And so, are there from a opportunity or strategies perspective, are there new strategies that's penetrating the materials market with greener tech? So that, yes, the corporates are interested in doing something, but, I think the traditional procurement model isn't going to work, right? Just to your point, Philip, what's new there or what's changing?
Well, what we're trying to do is what we've done is identify a niche market, right? That is very motivated to take on the challenges of changing their raw materials in order to be more sustainable. The customers demand it. The companies are trying to give the customers what they want for market share, for branding purposes. So we still need to identify materials that have the properties that they need, and we've got to develop the supply chains as well. But what we're trying to do is develop a process that'll fit into existing infrastructure, polymer production infrastructure, and work with the polymer production on a licensing basis rather than on a production basis, so that our customers, the fashion brands, are going to be comfortable that they're working with the same suppliers they already have. The suppliers themselves will be able to do this in small scale, relatively small scale, for these niche markets, and allow everyone to get their moves down, go to larger scale, get the costs down, and move from these niche markets then into different sectors that are going to be much more sensitive to things like supply chain and cost, but to be able to do that then on a stepwise basis.
Sure. What other, and this is to everybody, what other long-term challenges are left to be solved to really get this to scale?
Yeah, I might just start by saying that fossil fuel subsidies still exist today. So we're not really seeing the real cost of fossil fuels, let alone the cost of their externalities. So while I think the predominant part of the oil and gas industry is driven by fuel use, they're also increasingly relying on petrochemicals for their revenue as the price of oil fluctuates and goes down. generally, we need to see that change, because if that cost starts to be taken into account, then these other methodologies start really becoming cost effective. And that's still a major barrier, because these corporations, I mean, well, from what we've seen, a lot of corporations have goals, but their goals are somewhat long term. We've seen some fantastic pioneers in some of the Microsofts and Stripes and Shopify's that are paying to remove CO2 and paying to bring those costs down. But otherwise, the green premium is one that hasn't really been accepted, and it's not necessarily one that will be. So we need to find ways of really accounting for the real cost of petrochemicals and getting these alternatives in.
Thank you. Frederick, you want to jump in?
Yeah, I mean, what we've learned through kind of CDUV, it was interesting through the workshop. There are two main things I think appeared quite clearly. The first one is the need for better carbon accounting methodologies for Carbontech. So because you're using CO2, depending on where the CO2 comes from, how long your product is going to sequester the CO2, how much energy you put into your process, there's a lot of parameters. And depending on where you draw the boundaries on the system, you can claim different benefits. And I think that's going to be, it's going to be a little bit the wild, wild west until we get really proper methodology. There are a couple of out there. University of Michigan is doing great work in this space. And there is a national labs also published methodology that will be used as part of 45Q. But they were still at the beginning of using these, and it's not yet really established. So the accounting and then how companies and startups will communicate around their benefits, I think that's a challenge for the industry as a whole. The other one is maybe, CCS has been around for decades and has been primarily funded by the oil and gas industry, so was very well funded, established, has very strong policy advocates in the US, but also in Canada and overall globally. And I think with Carbontech, we need to do a better job at explaining what it is to the policymaker, and consider maybe starting to think about some kind of alliance, or at least how are you able to express the need for specific policies for Carbontech. It's not because you're making a product and you're going to have a revenue for a product that you don't have to get, that you're not facing huge challenges. Like Philip mentioned, the path to scale is still extremely risky and complicated. And so I think there is maybe some movement there to be seen around just more educating policymakers and maybe in general the public even.
Right. Still a lot of work to be done. Aaron, Philip, want to jump in on some of the long-term challenges that you see that still needs to get solved?
Yeah, I guess for me, I'll just, sorry, Philip, go ahead.
Well, what I was thinking about is the need for a democratization of Carbontech. We have to be able to come up with products that can be used not just by the rich, not just by developed countries, but by the developing countries and by the poor. And we need that partly in order to get to scale, but because it's really the poorer people and the developing nations that are facing the brunt of climate change. We need to be able to bring them into the solution as well by making materials that they all can use in order to really get the carbon out of the atmosphere.
Aaron?
I echo everything said, and I was just going to add that we're nowhere near the scale that we need today to, I think, even reach the long-term goals that we have. So for me, until the models indicate otherwise, our long-term goals and our short-term goals are pretty much the same. We need to develop, deploy, and commercialize more of these technologies. And that means more entrepreneurs need to jump in. That means more funders need to be willing to take the risk to bring these technologies to market.
Understood. Okay. Well, we're almost at the end of our session, and I just want to close it off by the crystal ball question, right? And so, where do you see us and the world in the next 10 years as we get Carbontech to scale? And, Aaron, kind of playing off of what you just said, how do you see this next 10 years play out?
Yeah. Well, I really think about this question in terms of the climate, and I don't want to be bleak, but acknowledging that we are in a crisis, which is why we're all here trying to do something about it. I personally see a lot of devastation happening, and potentially I see a lot of social conflicts that really continue to arise because certain areas of the planet are going to be really challenging to sustain life. And I think that's really makes it critical for us to collectively act today so we can minimize some of those bad effects that are the worst that's really yet to come. And I think if we're able to do that, and if we can start, I think we'll see a starting of a cascade of a lot of climate wins potentially. And if we can get Carbontech to scale specifically, I see a better world prepared to adapt to climate change than we have today. I see a world better equipped to address it as well. And in terms of addressing it, more cost affordable DAC. And when it comes to Carbontech companies here, I see dozens of publicly traded Carbontech companies investing large sums of money to further accelerate their global expansions to help further reduce the cost of carbon removal. And on the adaptation side, if Mars has its way, I see a future where carbon fiber is being used more regularly to decarbonize industry and as a strategic decarbonization tool. In this case, I see carbon fiber being used to replace steel components like steel reinforced conductor lines in California's entire electrical grid to reduce utility cost wildfires. I also see it being used to replace certain steel components in buildings, just as concrete amendments, to improve the longevity of buildings, and for even like the state of New York, for example, where its built environment will be its carbon storage environment because it doesn't have the space or the capacity to pump and store CO2 underground.
Great. How about you, Philip? How do you see the next 10 years change as we Carbontech to scale?
I think that success will breed success, and that there will be virtual cycles growing out of that. We'll see with the successful deployment of some elements of Carbontech and products being brought to market, we will see students that realize that there are jobs to be had in this area, and they will go into the technical fields necessary. We'll see companies get started in order to commercialize the techs that coming out of the universities and coming out of the national labs. And we'll see investors then seeing that there's money to be made here, and they will be investing in those companies. And this will all continue to cycle on, coming up with lots of brilliant ideas, some of which will make sense and some of which will make it to market, but in the aggregate will really make a difference. I think we're also going to see changes then, as we've noted, the availability of hydrogen to do electrochemistry. We're going to see huge changes in how that drives, how the need for hydrogen in all of these different areas, including Carbontech, how that drives more and more renewable energy being generated, and how that's going to completely change the way we see our energy sector, possibly to leave the oil and gas underground for a little bit longer.
Great. And Frederick, I know you're working as a part of a multi-year plan. How is this going to play out for you in the next 10 years?
Well, we're only a 3-year initiative, but yeah, it takes time to build an ecosystem. So I think that's why we are recognizing and building that over the next 3 years. But I think just going to Philip's point, there is a future where we have abundant, low, cheap, renewable energy again, and that's really key because if you think about it, we can do a lot of the chemistry that we are using today with oil. We can repurpose some of the equipment assets to feed CO2 and green hydrogen and react those two molecules the same way we react naphtha or syngas in a conventional oil and gas. And so that's also interesting. Like there is we don't have to completely shut down all the refineries. We can reuse some of the assets. Some of the workers can transition from using oil as a feedstock to switching to CO2 and hydrogen as a feedstock. So I think that's very interesting with Carbontech, and I hope that this is a war we're going to see. Personally, I like to still travel and fly. It's no mystery that I still have family in Europe, and I need to go there. And so I really want to decarbonize the aviation sector. I think electrofuel, so using electricity to react CO2 with hydrogen to make jet fuel, it could be a great solution. The costs are not here, but with a reduction of hydrogen costs, I think it's possible. And versus electrifying planes, this could be really a very strong proponent. So I do want to see a future where I fly on e-fuels in 10 years from now.
Fantastic. I think investors in general has to be the most optimistic, right? But also most influential and strategically valuable to breed success, breeding more success. And so, Clea, if I may have you close us out, where do you see us in the world in the next 10 years as we get Carbontech to scale?
Yeah, I mean, I think the panel has said most of it. It just needs to become the status quo, right? I think carbon offsets need to be carbon removal, and they need to be 1,000 times greater than what they are today. And with every material and fuel and anything that we consume, carbon to value needs to be a part of that. If electrification isn't, then it's carbon to value, and well, that's the future that I see.
So we'll still have Carbontech as a keyword and thing. I was hoping someone would say, "Oh yeah, we're going to be so successful in 10 years. This will be, there'll be no startups needed because we'll have solved all the world's problem." But
I do hope that Carbontech won't have to be defined as such, but really it'll just be tech.
Awesome. Fantastic. Thank you very much for all the speakers, Clea, Aaron, Philip, Frederick, and then of course Chris Carpenter, who is part of this program, who is working in the back end. Thank you very much, and for everybody that joined us today. Hope you have a wonderful rest of the day. And my name is Jay Onda. Thank you again.
Thank you.
Bye-bye, everybody.